Good morning students. Today we will discuss about Bloch theorem or electron moving in a periodic potential. So last classes we have seen free electron theory was developed in three stages. One is classical free electron theory, quantum free electron theory and another one is band theory. Band theory was proposed by Bloch. According to Bloch, electron move in a periodic potential. Here we'll see the statement of Bloch theorem. So what does Bloch theorem states? Here Bloch theorem states that when electron is moving in a periodic potential, the solution of any Schrodinger wave equation. So the solution of any Schrodinger wave equation is a modulated plane wave of the form psi k x is equal to e power ikx ukx. So what does this mean? See here, what is the Schrodinger wave equation we know? We know Schrodinger wave equation as dou square psi by dou x square plus 2m into e minus v by h cross square psi is equal to 0. This is one form of Schrodinger wave equation. If I go for another forms, dou square psi by dou x square plus 2me by h cross square. If v is 0, we can write it as 2me by h cross square psi is equal to 0. Or otherwise, if I can write it as dou square psi by dou x square plus k square psi is equal to 0. Or otherwise, if I write minus, whatever it may be, so whatever it may be, the solution of this Schrodinger wave equation, the solution for this Schrodinger wave equation is written as psi kx is equal to e power ikx ukx. Means the solution for this equation is this one. For this also same one. For this also same one. So the solution of any Schrodinger wave equation can be written like this. So here ukx represents periodic function. This is the periodic function which varies with periodicity of lattice constant A. Lattice constant A. This is the periodic function which varies with periodicity of lattice constant A. Okay. Now we'll try to explain Bloch theorem. Okay. Now we'll see how electron will be moving in the periodic potential. How electron will be moving in the periodic potential. So see here, if I consider a metal. So we know metal consists of atoms. So metal consists of atoms. In the metal, atoms are regularly arranged. In solids, atoms are regularly arranged. So metals will be having plenty of free electrons. So when the electrons comes out, atom is losing electrons. When electrons comes out, what does they become? They become positive ions. So losing electron, it becomes electropositive. So they become positive ions. These are the positive ions. Now, how potential varies in this positive ion cores? In between positive ion cores, how electron will be moving? So electron will be moving in periodic potential. Let's see how this periodic potential varies in Bloch theorem. Okay. Now the variation of potential, at lattice ions. These are, what are these? These are the positive lattice ions, positive ions. So these are positive ion cores. These are the positive ions. The distance between two atoms is represented by A, which is called as lattice constant. The distance between two atoms is called as lattice constant or interatomic distance. So how potential varies? According to Bloch theorem, potential varies such that potential is minimum at the positive ions. Potential is minimum at the positive ions and it is maximum in between positive ions. In between positive ions it is maximum. At the positive ions it is minimum. Okay, like this potential varies. See here, this potential is varying periodically. Everywhere it is varying like that only. In between positive ions it is maximum. At the positive ions it is minimum. Okay, now what is the Schrodinger one-dimensional time-independent wave equation? So one-dimensional time-independent wave equation can be written as d square psi by dx square plus 2m into e minus v by h cross square psi is equal to 0. This is equation number 1. Now electron is moving in which potential? It is moving in periodic potential. So that's why here potential V of x can be written as V of x plus A. Okay. Now, according to Bloch theorem, when electron is moving in periodic potential, what is the solution of this Schrodinger wave equation? So, the solution of Schrodinger wave equation can be written as psi k x is equal to e power ikx ukx. This can be written as e power ikx ukx. Next, this is the solution in one dimension. Next, in 3 dimension I can write it as psi k r is equal to e power ik r. R represents x, y, z. E power ik r uk r. This is equation A and this is equation B. So these are called as Bloch functions. So these are called as Bloch functions. So these are the Bloch functions in one dimension and 3 dimensions. These are the Bloch functions in 1 dimension and 3 dimensions. So in the above equation psi kx is called as periodic function which varies with periodicity of lattice constant A, or otherwise it is also called as modulating function. So see here, now if we see here in the diagram, if I say that n number of positive ions are there. So how many number of positive ions are there? N number of positive ions. The length of this chain is capital L. The length of this chain is capital L. So the distance between two ions is A. The whole length of the chain is L. So L is equal to how many atoms are there? N. And what is the distance between two atoms? A. So I can write it as L is equal to Na. So periodic function gets modified as ukx. Ukx can be written as ukx plus Na. So I can write it as ukx is equal to ukx plus Na. Now this is equation number 4. Okay. Now I'll substitute this. According to this, I'll substitute instead of x, I'll substitute x plus Na in equation A. So from equations 4 and A. From equations 4 and A, we can write it as ukx plus Na. Ukx plus Na is equal to ukx plus Na is equal to, I can write it as so here I can write it as uk x plus Na e power ik x plus Na. So implies I can write this equation as psi k x plus Na is equal to uk x plus Na. What is uk x plus Na from equation 4? From equation 4, uk x plus Na is ukx. So I can write it as ukx e power ikx e power ikna. So this is from equation 4. From equation 4 I can write like this. So I can write it as, here I can write it as psi k x plus Na is equal to, what is ukx e power ikx? So see here, what is ukx e power ikx is nothing but psi kx from equation 1. So this is psi kx. This is from equation 1. So ukx into e power ikna, this is from equation 1. So psi k x plus na, I got it as psi k x e power ikxa ikna. This is called as Bloch condition. This is called as Bloch condition. Okay. Now I want to know, here we are saying that electrons can move freely inside the metal. Electrons can move freely inside the metal, means the probability of finding electron is everywhere the same. See here, when I show here the diagram, here electrons are free to move anywhere. So I can find this electron here also. So the probability of finding electron is equal. So now I want to prove that. What is the probability of finding electron? How to find probability of electron? It can be found by modulus of psi square or modulus of psi star. Okay. Now this is equation number 5. Okay. Now I'll take complex conjugate. Complex conjugate of equation 5. So what is the complex conjugate of equation 5? Psi k star x plus Na is equal to psi k star x e power ik minus ikna. This is equation number 6. This is the complex conjugate of equation 5. Now how to get the probability? So psi k psi star gives the probability. So I can write it as, so how to get the probability? Now I can write it as, now if I multiply equation 5 and 6, if I multiply equation 5 and 6, so see here how I will get psi k x plus Na into psi k star x plus Na, which is equal to, see here e power ikna, e power minus ikna, so e power 0 is 1. So I will get it as psi k x into psi k star x. What does this mean? Psi k x plus Na is equal to psi k x. Psi k star x plus Na is equal to psi k star x. Means the probability of finding particle is everywhere the same. So here electron can be localized anywhere. So the probability of finding electron is everywhere the same. Okay. Now, so see here. So see here, this means that the electron is not localized around one particular atom. So it doesn't belongs to one particular atom. It will be moving throughout the metal. It belongs to whole metal. So the probability of finding particle is same throughout the crystal. Okay. Now, if I say psi k x plus Na is equal to psi k x, psi k star x plus Na is equal to psi k star x. So, if psi k x plus Na is equal to psi k x, what happens to this expression? Here psi k x plus Na is psi k x. So, psi k x, which is equal to psi k x e power ikx, ikna. What happens? These two get cancelled and I will get e power ikna is equal to 1. e power ikNA is equal to 1. So I can write this one as cos kNA plus I sin kNA. I sin kNA is equal to 1. But here 1 is real factor. So there is no imaginary part. So I can write cos kNA is equal to 1. For what value of cos? For what value of cos it is 1? Cos 0 is 1. Cos pi is 1. Cos pi will be minus 1. Cos 2 pi is 1. Cos 3 pi again minus 1. So here cos 4 pi is 1. So 0, 2 pi, 4 pi, 6 pi, so on. So this is 1. So I can write it as kNA is equal to 2 pi n, where n is an integer. So from this we can write k is equal to, see here, n I can take it as 0, 1, 2, 3, so on. So here k I can write it as 2 pi n by Na. So implies k is equal to 2 pi n by L. Na is nothing but L. So here n can take the values plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Okay. Now, so k is equal to 2 pi n by Na, which is equal to 2 pi n by L. Okay. Now, in any state, 2 electrons can exist. So, n is equal to n by A. So, k is equal to 2 pi n divided by, this can be written as 2na. So, this n get cancelled, this 2 get cancelled, k is equal to pi A. So, you can write it as k is equal to plus or minus pi by A. This is the edge of first Brillouin zone. So, this is all about Bloch theorem.